Alright, in this section we're going to deal with differentiation of parametric equations. We've done parametric equations. I give you a simple example. Let's say x equals to 2t, y equals to 4t squared. This is a simple example of a parametric equation. Now, to find a gradient of a curve defined parametrically, we use the chain rule. Let's not forget chain rule. Chain rule is when applied to y and t, okay, use dy dx is actually dy dt times dt dx. Now, I also want to say that dt dx is 1 over dx dt. So if we change this like that, if we change dx dt to 1 over dt dx, I beg your pardon, to 1 over dx dt, this is most useful to find dy dx, everything in terms of t. To illustrate it, if you can see here, therefore your dy dx, if you apply it directly, you differentiate y with respect to t, you get 8t. You differentiate x with respect to t, you get 2. Therefore, you get 4t. So essentially, that is how we apply this. All right, let's take a look at another example. All right, your example here, this is your parametric equation. You're required to find dy dx at t equals to 2. Now, we will use this method that I'm going to show here only if the algebraic method is required, only if the exact answer is required. Later in method 2, we actually just directly use the GC. Okay, I'm going to show how to use the GC. But before that, if suppose you are required to find exact or algebraic method is required, we have no choice. We will use the algebraic method here. So, in your previous screen, previous slide, you see that dy dx is dy dt divided by dx dt. So what I'm going to do, I'm differentiate this, you get 3x squared. Differentiate this. Yes, you will get a minus 2t over 3 plus minus 2t over 3 plus t squared whole thing squared. And this is your dy dt, this is your dx dt. Simplifying a little bit more, all right, it's equivalent to multiply of it. All right, reverse the numerator and denominator, simplify, we will get there. But what you are required to do is to find dy dx at t equals to 2. So what I'm going to do, I'm substituting t equals to 2 inside. Therefore, the final answer, I will get minus 147. That's method 1. If you are not required to use to give an exact answer, if you're not required to find an algebraic way, all I need to do is to go to the GC. Let me very quickly show you the GC. First step is to do this. You change or go to mode, right? Go to mode, and then you will change to a parametric mode. Okay, you go there, down. You go to a parametric mode. Press enter. And you go to y equal. You realize that you are required to define. This is not new to you. In curve sketching, you've done that before, so I'm not going to say so much. All right. But once you've done that, what you do, all right, you can see your graph, not a problem. But more importantly, you go to second trace, which is calculate the value of dy dx, number 2. They're going to ask you at which point do you want it. At which point you don't scroll left and right. You don't scroll left and right. You just type 2 in here because you are required to find the gradient at t equals to 2, enter. You realize that you get value minus 147. So therefore, answer by GC dy dx is minus 147. Alright, that's the method 2.